Now we will discuss about the linear differential equation of Legendre type. So here we can say Legendre type linear differential equation. This is looking similar to the Euler type equation, but here coefficient will be different than the Euler type of coefficient. So what is Legendre equation? The equation, the differential equation of the form ax plus b to the power n dny by dxn plus ax plus b to the power n minus 1 dn minus 1y by dxn minus 1 and so on. So ax plus b dy by dx plus an y equal to f of x is called the linear differential equation of Legendre types. Linear differential of Legendre types. Now, in the Cauchy-Euler equation, the coefficient was only x, but here the coefficient is in the form of ax plus b. So how can we solve such type of problem? If this type of problem is coming in your examination, then we will apply the transformation like this. Take ax plus b equal to e to the power z. Before you used to take x equal to e to the power z, but in this case we will take ax plus b equal to e to the power z, and that will give you z equal to log of ax plus b. Again we will convert this one, the initial differential equation with initially in terms of x, and we will transform it to the differential equation in terms of z. As a consequence, this variable coefficient thing will be reduced to constant coefficient thing. And once after getting the constant coefficient differential equation, we can apply whatever formula we know and we can solve them. And in terms of z, we will get the solution, and then after getting z, we will replace it by log of ax plus b. But thing is that because of this transformation, what we will get, wherever I am having ax plus b of d, I will take a d dash, and whenever I am having ax plus b whole square and d square, I will take a square d dash into d dash minus 1. Similarly, ax plus b to the power 3 dq will be nothing but aq d dash into d dash minus 1 into d dash minus 2 and so on. So like this we can take, and we can able to reduce the variable coefficient equation to a constant coefficient differential equation. And as usual, after getting the solution in terms of z, we will replace the z by log of ax plus b. So now let us take an example here. Let us take an example here. Solve x plus 1 whole square d square plus x plus 1 d plus 1 of y equal to 4 into cos of log of x plus 1. Okay, so this is the given differential equation. Now you see that this is in the form ax plus b, where a equal to 1 and b equal to 1. So what we will consider here? We will consider the transformation. Let x plus 1 equal to e to the power z, and then z will be nothing but log of x plus 1, log of x plus 1. Because of this transformation, what I will take, x plus 1 of d will be 1 into d dash, because a equal to 1 here, a equal to 1 here, and so it will be equal to d dash. Similarly, x plus 1 whole square into d square will be 1 square d dash into d dash minus 1. Okay, so now substituting these things in the given differential equation, we can have d dash into d dash minus 1 plus d dash plus 1 of y equal to 4 into cos of log x plus 1 is nothing but z. Log x plus 1 is nothing but z. And this means d dash square minus d dash plus d dash plus 1 of y equal to 4 into cos z. 4 into cos z. You see, plus d dash minus d dash are getting cancelled, and the remaining thing will be d dash square plus 1 of y equal to 4 cos z. Now we can find the complementary function, as well as we can find the pi. So what will be my complementary function? Let d dash equal to m, and so the auxiliary equation will be m square plus 1 equal to 0, and m equal to plus or minus I. So the root is real complex, and so the complementary function, where real part is 0 and the imaginary part is 1, so complementary function will be nothing but c, we can have x to the power 0, sorry, z, x to the power 0 c1 cos, beta means 1, beta of log x plus 1, or better you can write another step. Complementary function is nothing but e to the power 0 z into c1 cos, beta is 1, so I will have here cos z plus c2 sin z, but z is nothing but log of x plus 1, e to the power 0 z is 1, and so I can have c1 cos of log of x plus 1 plus c2 sin of log of x plus 1. So this is your complementary function. Now let us find the pi. Pi will be nothing but, pi is nothing but 1 by d dash square plus 1 into 4 cos z. 4 cos z. So here what we will do? We will replace d dash square by minus 1 square, because here cos a z means a equal to 1, and so we will have 4 will be outside, 1 by minus 1 square plus 1 cos z. So that equal to 4, 1 by 0 cos z. So what we will do? 4 will be as it is. We will multiply z, and we will differentiate with respect to d dash, and the thing will be like this. The thing will be like this, and this is equivalent to 4z divided by 2, 1 by d dash cos z. 1 by d dash means integration with respect to z. So we will have 2z, 2 1 ja 2, 2 2 ja 4, 2z and integration of cos z dz. Integration of cos will be sine, and so we can have 2z sine z. But z equal to how much? Z equal to log of x plus 1. And so final particular integral will be 2 into log of x plus 1 into sine of log of x plus 1. Okay, so this is my particular integral. So once after getting particular integral, complete solution will be complementary function plus particular integral. So I would like to take another example here. Example, solve 2x plus 3 whole square d square y by dx square minus 2x plus 3 of dy by dx minus 12y equal to 6x equal to 6x. Now you see that the equation is in the form ax plus b whole square d square y by dx square and ax plus b dy by dx and y equal to some function of x. So this is a Legendre type equation where here we will have a is nothing but 2, b is nothing but 3. So now what we will do? Now we will take the transformation 2x plus 3 equal to e to the power z. And because of that, what will be your z? Z will be log of 2x plus 3. 2x plus 3. And 2x plus 3, because of this transformation, 2x plus 3 of d will be nothing but 2 into d dash. And and 2x plus 3 whole square d square will be 2 square d dash into d dash minus 1. And so this is equal to 2 dash, and this will be 4d dash into d dash minus 1. Now substituting these values in the given differential equation, we can have 4 d dash minus 1, and then minus 2 d dash, and then minus 12 of y equal to, you see that the right hand side we have only 6x, but we are considering here 2x plus 3 equal to e to the power z. So now we will try to make it in the form of 2x plus 3. So we can write 6x like this. We can write here 6x can be written as 2 into x, 2x, say 3 into 2x plus 3. That means 3 I am taking common, 3 is 9. I have added 9, so I have to subtract 9. I have to subtract 9. So I can write in this way. 6x can be written as 3 into 2x plus 3 minus 9, and I will have 3 in place of 2x plus z, 2x plus 3, I can write e to the power z minus 9. Minus 9. And so simplifying this one once again, we will get 4d dash square minus 4d dash minus 2d dash minus 12 of y equal to 3 e to the power z minus 9. And this implies 4d dash square minus 6d dash minus 12 of y equal to 3 e to the power z minus 9. So auxiliary equation will be 4m square minus 6m minus 12 equal to 0. And this is equivalent to 2m square minus 3m minus 4 equal to 0. Equal to 0. So if you can factorize it, 8 and this 3 will be, sum will be minus 3 and product will be 8. If you can able to factorize that one in that way, you can factorize. Otherwise m will be 3 plus or minus root over of 9 minus 4 into 2 into minus 4 divided by 2, and so that will be 3 plus or minus 9 plus 1632. So we can have 9 plus 32, 4 into 4 30, 4 into 4 16, 16 to the 32, 32 plus 9 is 41 root over divided by 2, divided by 2. So the roots are real and distinct. The roots are real and distinct. And so the complementary function will be, how can we write it? So two roots are here. We are having m1 equal to 3 plus root over of 41 by 2, and m2 will be 3 minus root over of 41 by 2. And so we will have the complementary function in this way. Complementary function will be c1 e to the power 3 plus root over of 41 by 2z plus c2 e to the power 3 minus root over of 41 to z. And finally z equal to log of 2x plus 3, log of 2x plus 3, log of 2x plus 3. So what we will get here? We will get here like this. We'll get here the thing is c1 2x plus 3 to the power 3 plus root over of 41 by 2 plus c2 2x plus 3 to the power 3 minus root over of 41 by 2. This is my complementary function. Now I will find pi. Pi will be 1 by d dash square 4d dash square minus 6d dash minus 12 into, what is the thing there, 3 e to the power z. So we have 3 e to the power z minus 9, and we can write in this way, 1 by 4d dash square minus 6d dash minus 12, 3 into e to the power z minus 9 will be there, 1 by 4d dash square minus 6d dash minus 12 into e to the power 0 e to the power 0 z. And so finally what you will get, 3 divided by 4 into 1 square minus 6 into 1 minus 12 into e to the power z minus 9 into 1 by 4 into 0 square minus 6 into 0 minus 12. Okay, and finally what you will get, 6 minus 6 minus 12 minus 18 plus 4 is 14. So 3 minus 14 e to the power z minus 9 by minus 12, minus 9 by minus 12. And so you can have 9 by 12 is 3 by 4, 3 by 4 minus 3 by 14 e to the power z. But e to the power z is 2x plus 3. So we will have 3 by 4 minus 3 by 14 2x plus 3. So this will be your pi. Once after getting the pi, you can write your complete solution. Complete solution is equal to complementary function plus particular integral. That will give you the solution.